Hey guys, so today I've got a really exciting and interesting educational video on Qubic, and I think this is one of the most interesting learning videos that I've ever done on Qubic, and I think that you'll probably see anywhere about Qubic right now. So this is going to be theory heavy. Probably going to be a bit boring for some of you guys who want to just be like, when is Qubic going to hit 1 cent or any of that sort of stuff? But for you guys who really want to understand Qubic and understand what makes it so unique and so powerful and why you can be bullish long term and think that 1 cent is possible long term, this video is for you and is going to explain it. So let's get into it. So yeah, guys, in this video, we're going to discuss Qubic Quorum and the bigger picture of how it's kind of like a decentralized government and how it affects everything. And we're going to use, this might seem lazy, but we're going to use a lot of ChatGPT definitions for this because ChatGPT has actually become so much more knowledgeable about Qubic and it provides a lot of great information. Of course, as always, ChatGPT can't be trusted on everything, but it's pretty, with my understanding of how the quorum works, I can see that it's pretty accurate, and any place that it's not accurate, we can fill in the gaps as we go. So let's talk for people completely new to what the quorum is. The quorum is a group of validators called computers, in the Qubic protocol, which is obviously a project from Sergei Ajincheglo. And basically, the computers, they're all nodes. So they're just like one large super powerful computer node that the Qubic network runs on, and there's 676 of these. And this is just a kind of example of what it would look like with 24 computers, but you can expand that out to 676 computers. So they're all connected to each other, and they all centrally controlled, or they all centrally give their power to the Qubic network. So they power the Qubic network. So everything happens through these, and it's really, really interesting how it all happens. But the bigger picture of this is it's basically like a government. The quorum is the government that oversees everything on Qubic and makes all decentralized decisions. And as you'll see as we go through this video, they are very, very much incentivized to make good decisions on Qubic's behalf. So let's go and look at some of this stuff. So here's the breakdown of how it works. So the Qubic protocol is a decentralized compute and smart contract platform that uses quorum-based consensus rather than the traditional blockchain mining or staking. So it's quorum-based rather than the traditional kind of models that we're used to. So computers are specialized nodes that participate in validation and execution of computations. We'll go into more detail on what that means soon. And then the quorum is the 676 computers that collectively validate transactions, execute smart contracts, and secure the network. So that's basically what they do in a nutshell, is they validate all the transactions. So they agree on transactions that occur in the network. They execute smart contracts and agree on what's happening with smart contracts. They secure the network. And then in a wider scale, they make all decisions or vote on all decisions that happen on the Qubic network. So each epoch, so this is how it works. Each epoch, a group of 676 computers is selected to form the quorum. These computers vote and reach consensus on transactions, contract executions, and Oracle data. Quorum decisions are binding once the majority agrees the result is final. The quorum can also run Qubic smart contracts, which apparently are called Qubics. I could be wrong by that, but that's what it says here. But that could be wrong. And then, which are computations agreed upon by consensus. So the Qubic Quorum is the core consensus body of the Qubic network, consisting of 676 computers, ensuring trusted validation and decentralized execution of tasks. That's all an overview. We're going to get a little bit more into that as we go along here. So let's just dive a bit more into the computers and the quorum size. So the Qubic protocol fixes the quorum size as 676 computers. So there's only ever 676 active computers. These are the only nodes that actively validate transactions and run smart contracts. Other non-computer nodes can still use the network, but they don't directly vote. So there could be other nodes, like 1,000 other nodes that use the network, but they don't directly vote and they don't get paid or incentivized to use the network. But the most successful ones and the best performing ones are the computers, the top 676. So then we've got what are called epochs and elections. So time in Qubic is divided into epochs. So there's ticks and epochs. So ticks happen, I think right now it's about every second or every 2 seconds. And then epochs happen every week. So they're fixed time periods. At the start of each epoch, so at the start of each week, which is on Wednesday at 12 UTC, the network runs a computer selection election to decide who becomes or remains part of the quorum. This ensures that the quorum is dynamic and fresh participants can join and inactive bad actors are removed. So this is always in flux, and whoever benefits the network more gets elected into the network and becomes a computer, and whoever is possibly a bad actor doing something bad for the network, or someone who just isn't acting very efficiently, maybe they're not preventing DDoS attacks, for example, or they're not preventing spam on the network, they get removed and they're replaced with someone who's better able to perform. So the election process. Candidates, so anyone can register as a candidate by staking and signaling readiness. So anyone who's a node can just register that they want to be a computer and then signal their readiness to do it. Then the voting happens. So existing quorum members and community participants can vote via on-chain mechanism. And there's a selection. The top 676 candidates by votes form the next epoch's quorum. So it's constantly dynamic, constantly changing. I mean, I'm sure you've always got this core 10 or 20 members of the quorum who are in the top 676 spots who are really efficient, are really doing things correctly. And then you've got battles lower down for people who are trying to become more efficient. And then probably on the lower end, you've got these computers who aren't super efficient right now, and other people are looking to come in and replace them. It's kind of like if you're in sports, the way there's promotion and relegation from divisions. Well, some nodes are looking to get promoted to computers, and then the poor performing computers are getting relegated and just turning into regular nodes. So incentives and removal. So why would you want to be a computer? So computers are rewarded for participating in consensus, securing the network, and executing smart contracts. So the way they're rewarded is the Qubic network initially emitted 1 trillion Qubic per week. Now I think it's around 470 billion, something like that. I don't know the exact number. And that's split between all the computers. So they receive the computers receive an equal share of that. Potentially the higher ranked you are, you might receive more. I'm not sure if that's true though. And then slashing or removal. If a computer is offline, if they're acting maliciously or failing duties, it risks becoming voted out or losing rewards in the next election. And there's a really interesting mechanism in here called the arbitrator that can identify who's not acting in the best interests of the network and remove bad actors. And that's a decentralized mechanism as well. But I'm not going to break that down in this video. I'm going to break it down in a separate video, but it's super interesting as well, the way that works. So the key idea of all this is that the Qubic Quorum is not static. I've talked a lot there, but the key idea here is that it's not static. The quorum is re-elected every epoch, ensuring that the network remains decentralized, adaptable, and resistant to long-term capture by any single group. So the big picture of this is this is game theory in action. You've got people constantly, or nodes, but they're people at the back of them, constantly competing to be within this quorum, to receive rewards, to make profit, and that's their incentive. And they need the Qubic network to be better and better and better, and earning more money so that they can be more successful. They need the Qubic price to be more and more, higher and higher to be worthwhile. And also, anyone who's a bad actor or isn't acting in in a way that benefits the network is going to be identified and removed each epoch. So yeah, in short, new computers join by winning votes in elections held by each epoch, and if they stay reliable and keep community support, they can remain the quorum. Otherwise, they can be replaced. Really basic idea, but really interesting. it's like a government. This is decentralized governance. It's like a government, but the votes are held way more regularly, and you're incentivized to do well. You're not like in our traditional governments that we have that are apparently democracies, where people are just lining their own pockets. This is, that's fine, lining your own pockets. But the problem with our governments is that people are actually incentivized to line their own pockets in a way that negatively impacts their country. But on the Qubic network, the way it's set up is that the quorum members obviously want to line their pockets, but the way that they do it is by improving the network. So they're incentivized to actually do good for the network. So it kind of fixes the issues that we have with democracy. So consensus in Qubic Quorum. So unlike traditional blockchains like proof of work or proof of stake, Qubic used quorum-based consensus model where votes are the main currency of trust. Now, that's a mouthful. We'll get into a bit more what that means. So we've got transactions and messages. So users send transactions or smart contract inputs to the network. Computers collect these into batches similar to blocks, and then each computer proposes their view of the state. Let me explain what that really means. So if you've got a wallet and you want to send one Qubic from that wallet to another wallet, that is a transaction. Then if you've got 1 million people doing the same thing, and you've also got, 100 smart contracts executing at the same time, and oracles taking in data feeds at the same time, and you've got things happening on apps, all that sort of stuff. Well, the quorum, all six. So, in a traditional world, a bank, for example, would be decentralized intermediary that would look and say, oh yeah, John sent 1 Qubic to Gary down the road or something like that, and the 1 Qubic switched places. A bank would do that centralized, but Qubic being quorum based and based on Byzantine fault tolerance, it's based on the computer's vote. So 66%, or over 66, so I think it's 67% of the computers need to agree that a transaction happens. So the 67% of them need to look and say, yes, John sent 1 Qubic to Gary. We agree, and that's agreed on. And once they agree on that, the transaction happens. Now, obviously, a tick is happening about every 2 seconds. So the quorum can't go and review. You might have 1 million transactions eventually going through in those 2 seconds. So the quorum can't look at all those transactions happen. So they've got a software that's running and it's just scanning and seeing, did this transaction happen? All the other 676 quorum members are doing the same scan, and they're seeing, did it happen? And once they all agree, it's sent through. Now, if for some reason, like someone was sending a false transaction into the quorum network in some way, they would all see through their automated software that, this actually isn't happening. That's my very simple understanding, but my best understanding of how this would work. So then we've got voting. So every computer has to vote on what it believes is the correct result of a computation, transaction order, or contract execution. So that's just what we're saying, the 67%. These votes are cryptographically signed and broadcast to the rest of the quorum. So it's just happening constantly. Every 2 seconds, I think it is, a tick happens. And then at the end of the epoch, it's all added and scraped off to kind of a past thing, and a new epoch starts. Once a supermajority of computers, so more than 2/3 of the 676, agrees on the same result, that decision is finalized. This ensures that a small group of bad actors, up to 1/3 of quorum, cannot break consensus. And then those bad actors would be removed over time. We'll explain that more in detail as we go ahead. But yeah, that's it. It's really, really kind of simple, but it sounds a bit complicated. But when you break it down, it's really simple. Is these guys just get voted in on how much they can benefit the network and prove that they benefit the network, to keep their position or lose their position on how positive they are for the network, how negative they are for the network. The more positive they are for the network, the more they're going to get paid. If they're negative for the network, they're not going to get paid and they're going to get removed. And then they just vote on everything that's happening on the network to say, yeah, we saw that this happened, or we didn't see that this happened. An example of voting that happened recently is, if you followed one of my recent videos, I submitted a proposal to make some videos. I submitted that proposal and it got voted on the quorum, and over 67% agreed, yeah, we're going to pay this guy to make some videos, and that's how it got put through. So it's just a quorum vote that happened. Now, that wasn't an automated quorum vote. That was one where they reviewed a proposal and they actually then made their vote based on reviewing the proposal. So the properties of the quorum model. So the properties are deterministic finality. So once the quorum finalizes a result, it cannot be reversed. So no forks like in proof of work blockchains. So this is why we've got Qubic saying that they have real true finalization when a transaction happens. The minute that the quorum just finalizes the result, that's it, truly finalized. It's parallelizable. Multiple Qubics. So apparently a smart contract is called a Qubic. It can be executed at once, since quorum consensus works on contract level computations too. So that is a big deal. We'll get into that a bit more later in the video. And then efficiency. Efficient, because there are only 676 computers, consensus is much faster than having thousands of random nodes try to agree. So this is just a really efficient process based on keeping decentralization, but also focused on speed. So there's a little trade-off there in terms of that you're not going to be as decentralized as Microvision, I think it's called, or what's that one called? Space Mesh, which is super decentralized. You're not going to be as decentralized as Bitcoin, but you're still decentralized enough that no bad actors taking over the network, and the whole community can get overview of what's happening on the network and give feedback. And at the same time, you're working way quicker than other networks. So in some respects, some people might say this is more decentralized because there's always going to be 676 pools. Well, if you look at Bitcoin recently, two major pools are up to 51% control of the Bitcoin network. And if they start colluding with each other, they have complete control over the network. That is much harder to achieve with Qubic and in the quorum. And then there's great security against attacks. So Qubic is Sybil resistant, so you can't just spin up many nodes because only elected computers matter. Is Byzantine fault tolerance. So as long as less than 1/3 of the quorum is malicious, the network still functions correctly. And accountability. Misbehaving computers can be identified since all votes are signed and voted out in the next epoch. So if you're misbehaving, you're going to be voted out very quick. So inside an epoch, the quorum reaches consensus by voting, with decisions finalized when over 2/3 of the computers agree, and this gives instant finality, high security, and efficient smart contract execution. So just what's interesting here is what you've seen happen with Monero recently is very difficult to happen on the Qubic network, and that's exciting to see. So then let's talk about Qubic's oracles and the quorum. So we talked about oracles in the past, but I didn't understand how unique Qubic's oracles are because they interact with the quorum and they actually are decentralized oracles. So we start off here with why oracles. So most blockchains can't natively know what happens outside their network. They don't have things like real world data like prices, weather results, sports results, AI computations, etc. Ethereum and others rely on third-party oracle services like Chainlink. Qubic instead bakes oracles directly into the quorum consensus. So how oracles work in Qubic. Anyone can submit external data to the network. So they can submit that Bitcoin prices, weather reports, AI model output. And then this data is treated as an input to a Qubic contract called a Qubic. Apparently, again, I don't know if it's called a Qubic, but apparently it is. And then this according to ChatGPT. Then the quorum, wait now, lost the page. The quorum computers then vote on the data's validity, just like they vote on transactions. So again, this data is being fed in. So what an oracle is it connects to real world data. So for example, a sports match might be happening between Man United and Arsenal win 1-0, and that oracle is attached to the game. It's getting updates as the game's happening, and then at the result of the game, it says the final result was 1-0. The quorum, again, through their automated system, they've got 676 feeds coming into each of those nodes. Each of those nodes looks at the result and then agrees, yeah, that data was true or that data wasn't true. So it's a decentralized format, and it's because it's decentralized, it's not open to so much malicious behavior. So consensus and oracle data. So each computer independently verifies the external data via APIs, crawlers, sensors, etc. So that's how they're verifying the external data themselves. So again, it comes down to whether a quorum member is efficient or not. The more efficient ones will have great ways of verifying data, while others mightn't be so good. Then the computers cast votes on what they observed. If over 2/3 of the quorum reports the same value, that becomes the truth recorded on chain. So the data is agreed. So the use cases for this are decentralized finance, so reliable price feeds for assets, AI as a service, so run computations off chain and verify results via quorum voting, prediction markets, so settle bets based on real world events, and Internet of Things and sensor networks. So integrate physical world measurements. So that could be just temperature readings for the weather. Prediction markets is an interesting one because there's a app on the Qubic network called Quotary, and it's a betting app. And basically it means that anyone using that app, like for example, I could go on that network now and I could say, I could create a bet and say who will win between Arsenal and Man United and give 4 different results for the score. And then people can bet on that. And then in a completely decentralized manner, the oracle result comes into Quotary. It looks at the score. The quorum all votes then on what they saw the score as. Say it was 1-0. All the people who voted 1-0 get paid out in a smart contract instantly. So it's a really, really powerful idea, and you can see how this is going to really expand in the Qubic network soon. And then why is it secure? So traditional oracles have single points of failure or trust bottlenecks, so they're basically not decentralized in many respects. Qubic's quorum oracles are decentralized, since 676 computers must collectively verify the data. Even if some computers lie, unless over 1/3 colluded, the truth will always win. And if people are lying and colluding, they'll get removed from the network. So it's not, and they won't get paid anymore. So it's not economically viable for them to lie. So in short, Qubic turns its quorum into a giant decentralized oracle machine. Instead of relying on an external oracle network, the same computers that secure transactions also secure real-world data inputs. That, I mean, I know it's long-winded, and I know it's a lot of theory, and it's probably kind of boring for some of you to watch this, but that blew my mind. And if I recommend going back over this part of the video again to understand it if you don't yet, because those decentralized oracles working on-chain in such a quick manner, it's mind-blowing. It's so unique, and it really makes Qubic so unique. So then let's talk about the smart contracts. So again, we're looking just at the big picture of how all this works together. So a smart contract, again, as I said, apparently it's called a Qubic. According to ChatGPT, I don't know if that's true, but it says a Qubic equals a smart contract, a program that runs on the Qubic Quorum. Unlike Ethereum contracts, a Qubic can receive oracle data, so can pull external data. It can run computations in parallel because obviously the power of the Qubic network, it can start computing on that data, which is, again, a mind-bogglingly powerful thing. So if you think of this useful proof of work network, it's able to take all that computers mining, or all that the miners mining power, and redirect it towards something useful. It's able to run computations on data as it's fed into the network, and it can scale very, very high because of the way this is set up and interlinked with Quorum. So you've got data coming in from oracles, computations are running on it through useful proof of work, And then based on the results, smart contracts are executing, and this can be done at scale. So how a Qubic works, so the deployment, a developer writes the logic of a Qubic. So for example, if a certain condition is met, pay out $100,000. The Qubic or smart contract is uploaded to the network, and the inputs can be something like user transactions, so like bets, transfer parameters, Oracle data. So you've got inputs like as data comes in about a match, and a result from match comes in, a smart contract executes, and it can once a smart contract executes, it'll make a payout to people. So you can sensor readings come in, AI inputs. And then the execution again is by the quorum. So each computer in the quorum runs the Qubic code deterministically. They cast votes on the result of the execution, and if 2/3 agree, the result is finalized. Again, this is all happening in a software that they're running, and this is happening every 2 seconds. So it's really, really fast, and they're running all in parallel at the same time. Outputs. So Qubics can trigger payments, state updates, or further computations. So those are the type of outputs that can happen. I hope that's self-explanatory enough without diving deep into it more and boring you. So examples of Qubics in practice. So here's where it gets interesting. So decentralized finance price feed contract. So Qubic Quorum fetches the Ethereum US dollar prices from multiple exchanges. Qubic finalizes a trusted on-chain price feed, and then it's used for lending, trading, or stablecoins. So that's one use case. Another is an AI computation contract. Someone submits a request, run this machine learning model on my data set. The quorum computers execute the model in parallel. They vote on the result. The final answer is returned and verified. Super, super powerful for outsourced computations where people want to run an experiment on the Qubic network and they want a unbiased opinion on the results of some of their work. They can submit a request, run that model on the Qubic network. The computers run the quorum computers run the model, and then they all vote on the final result. And if 67% or more give a final result, then it's returned and verified. So this is going to mean this is going to be a big deal for science, basically decentralized science, if that makes sense. So DeSci. And then for prediction markets, so users bet on will a certain candidate win an election. After the election, the quorum computers fetch the result from trusted news sources, and then Qubic settles the bets automatically. So a user bets, then the oracles go and fetch the data, and then a smart contract just automatically pays out on who bet correctly. And that's been done already with Quotary on the Qubic network. And then Internet of Things sensory data. So sensors submit temperature or weather data. The quorum verifies the readings. And then a Qubic could, for example, trigger crop insurance payouts if rainfall is under a certain threshold. That's just so interesting. So, the sensors submitting the temperature or weather data will come through an oracle. Then each of the quorum members would verify those readings. And then if 67% of them or more agree on those readings, it would trigger then something like a crop insurance payout, or it could lead to further computations. Maybe the further computation would go and give advice on what the farmers could do, or crop owners could do to improve things. Or maybe like in a really, really crazy world, something would happen where sprinklers would turn on in crops if the rainfall wasn't meeting a certain area. Like that's the bigger picture on Internet of Things. So it'd be Internet of Things outputs as well as Internet of Things sensor inputs. So why Qubics are special then? So why Qubic smart contracts are special? Integrated oracles, so that's really, really important. Decentralized oracles, parallelism. I'm sorry, I'm so bad at pronouncing some of these things sometimes. Thousands of Qubics can run side by side, unlike Ethereum's single-threaded model. So it's super, super fast. As we know, Qubic can do 15 million smart contract transfers per second. So it can run a huge amount of smart contracts very, very fast. And that's not the upper limit for Qubic. As hardware power increases, then as hardware power increases, then the Qubic network can scale. So just as hardware gets more advanced, basically, the Qubic network can scale with it because each quorum member can do more computations. So probably in the future, you're going to see the Qubic network being able to run billions of smart contract transfers per second, which is mind blowing. So then it's the deterministic finality. Once quorum votes is final, no forks, no probabilistic settlements, was instant finality. And then computation marketplace. Anyone can rent the quorum's compute power, which is mind blowing as well. So when you think about all these miners all over the world putting their power onto the Qubic network, and then people can actually rent that power. So you can be a science company that wants Qubic to run a computation on your machine learning model and get a decentralized proof of whether something is viable or non-viable. That will be possible, which is amazing. So in summary, a Qubic is a programmable contract that can use both user inputs and real-world Oracle data executed by the Qubic Quorum. This makes Qubic more like a world supercomputer than a typical blockchain. I hope this is... I know there's a lot of information in here, but I hope it's kind of blowing your mind a bit and seeing the potential of what Qubic really is. We're not talking about crypto here. We're not talking about blockchain. We're talking about something much bigger. And we haven't got into the real juicy stuff even yet, because the bigger picture of what they're trying to do with this is mind blowing. So then if we talk about the economics of the Qubic token, so the Qubic token is a native currency. The purpose is it's a unit of payment for running computations, storing state, and incentivizing computers. So it's basically just it's like the fuel of the network is really what a Qubic is. So the economic flow, so users pay for computations. So if you deploy a Qubic smart contract or send a transaction, you must pay fees in Qubic. This prevents spam and makes resources scarce and valuable. Now, so this is ChatGPT making a mistake here. So if you actually send a transaction wallet to wallet, it's feeless. But if you're deploying smart contracts or using apps, there is a small fee and a burning mechanism involved in that. So it's mostly true, but it's not true in fees from wallet to wallet. So fees go to computers. So computers then, so the 676 quorum members split the computation fees. So the fees are some fees, again, this isn't entirely true. So I think some fees might go to the computers, but it's actually the emissions that happen every week that pay the computers. But there probably are more things like computation fees and things like that the computers get paid on as well, but I'm not sure of the full details of this. The more work they perform, so processing contracts, validating Oracle data, the more they earn. I mean, this does actually sound like it's something that is in the network. So I always thought that the computers just get paid on the emissions that happen, emissions that happen every week. But I'm guessing the more work they perform, they'll even earn more in terms of fees as well. I'm not 100% sure about that, to be honest. This could be something that ChatGPT is wrong, and I'll have to explore more over time. So the quorum, elections and competitions. So to join the quorum, the candidate often needs to invest Qubic, so like staking, campaigning, or advertising. So again, you've got to make an investment to actually become a quorum member. So it's not easy. And this creates demand for the tokens, since only elected computers get rewards. So it costs quite a bit to be a quorum member, just in terms of the hardware you have to run, the electricity costs, just the general work that you have to do to be a quorum member. So it's not easy. So there's a lot of competition for these spots. The reward distribution, then rewards are split based on performance and honesty. Honest computers who stay online and vote correctly get their share of rewards. Malicious or inactive computers lose rewards and risk being voted out in the next epoch. The incentive design. Users want reliable computation and real-world data, pay Qubic. Computers want to earn rewards, stay honest and efficient. And token holders want scarcity and utility, benefit from demand as network usage grows. So the example is, imagine a prediction market qubit handles $1 million in bets. Every bet has a small fee in Qubic. At settlement, the core computers execute the contract, verify the real-world outcome, and get paid. Honest computers profit, dishonest ones get nothing. So that probably is true. I'm learning here now that I didn't realize that the core members also get paid a small fee on top of everything. I thought the fees went to the app owner, but probably some of that fee actually goes to the quorum members as well. So that's really, really interesting. So why this matters? So unlike Ethereum, gas fees to miners and validators, or Chainlink, a separate Oracle network, Qubic unifies compute, oracles, and consensus all in one system, all powered by the same token. And this creates a closed economic loop where demand for real-world computation equals the demand for Qubic. So basically, you've got this huge computational network that people are demanding, or will in the future be demanding access to, and the only way to access it is by owning Qubic, which creates a real demand for Qubic. So this is a real use case we've got here. People need Qubic to access that underlying network that's been built. So in summary, users pay Qubic to run contracts, computers earn Qubic for consensus and computation, elections create competition, keeping computers honest, and the result is a self-sustaining economic engine for a decentralized supercomputer. And this is, again, what I'm really trying to get across. You think of that supercomputer, it's all powered by this useful proof of work. So all these miners, people all over the world, just logging on with their laptops, their phones, their more powerful computers, are mining Qubic. And with other traditional blockchains, that compute power is all going to waste. Even though that compute power is worth hundreds of millions, probably in the case of Bitcoin, and God knows how much it is worth. With Qubic, though, that compute power can be accessed through this useful proof of work model, and it can run computations, it can run smart contracts, it can do all sorts of things. And the only way for you as a user to access all that computational power is by owning Qubic. And right now we're seeing that useful proof of work being directed towards mining Monero, which is, they might take over the Monero network. We have to see how that goes. And of course, the bigger picture of all this is that Qubic then is trying to build on-chain AI, and that on-chain AI is going to have access to the oracles to be able to get real-world data feeds, smart contract to auto-execute things as they happen, to be able to affect the world through these outsourced computations, to have all that computational power. At the same time, you've got a thinking mind living on this network. I mean, it is so genius. If this works, it's going to be huge. Qubic's just going to be huge. Anyway, guys, I know that was very long-winded. A lot of theory in there. Feels like a boring college lecture. But I really wanted to just dive deep into what the actual quorum is and why it is so unique, and why Qubic isn't a blockchain. It isn't crypto. That's a very small part of what Qubic is. This is way bigger. It's a supercomputer, a computational power machine, completely decentralized, with a decentralized AI. Apparently, we have to see the proof of this yet, but a decentralized AI going to live on the network. That's all I've got for you today, guys. I'll see you all on the out.